Okay, welcome back to our Department of Art Visiting Speaker Series. Glad to see we have a nice big group tonight in the grid. This evening, of course, Adam Brown visits us to share his work. Brown is an internationally recognized conceptual artist whose work incorporates art and science hybrids, including living and biological systems, robotics, molecular chemistry, and emerging technologies. Brown's creative research is informed by a background in Intermedia. Felipe Shibuya, a graduate student here in the UB Department of Art MFA program, is with us today as well. Felipe will extend an introduction of Adam Brown to our audience this evening, speaking from the point of view of an artist also working across disciplines and engaging with methodologies developed here in the BioArts Coalesce Lab, among other things. Together, we're pleased to welcome Adam Brown to UB. Please activate cameras as usual, turn off your mics until the conclusion of the talk. Adam and Felipe, thank you for joining us. Felipe?
Hi, Max. Hi, Adam. Thank you so much. I'm super excited to introduce tonight Professor Adam Brown, especially because we share the same passion to work with bacteria, color, and nature. So it's a pleasure to be here tonight listening to your talk. So Professor Adam Brown is an internationally recognized artist, scholar, and educator whose work incorporates art and science hybrids, including living and biological systems that examine how human entanglement with other species shape our histories, stories, and myths. Brown has exhibited in 12 countries, received 3 prestigious awards from Prix Ars Electronica, Avida 14 Award, and most recently, the 2020 Grand Prize at the Japanese Media Arts Festival. His work has been writing about widely in diverse publications such as the New York Times, Wired, Nature, Sculpture Magazine, Washington Post, Forbes, the Proceedings of the National Academy of Science, Discover, and the Huffington Post. Brown currently is associate professor at Michigan State University, where he created a new area of study called Electronic Art and Intermedia. In addition to active teaching and research practice, Brown directs the Bridge Artists in Residence, a program designed to immerse national and international artists with the creative space of scientific inquiry and research at MSU, connecting the arts, science, and humanities. So please welcome Professor Adam Brown. I'm looking forward to hear your amazing talking tonight. Thank you, Adam.
Okay, thank you for that introduction, and thank you for everyone to take the time to listen to my spiel. Let me start by sharing my screen and make sure I can get that working properly. Just give me a second. Okay. Okay, so my work spans art, science, and the humanities in order to enact a practice-based research epistemology. The art is made via an intensely iterative process which combines historical, philosophical, political, and cultural investigations with scientific methods, practices, and deep collaborations. Insights learned through the making of these living systems also reflect a deep collaborative engagement with scientists and scholars, which is then fed back directly into the artistic output. Due to the complexity and interdisciplinarity nature of the artworks, most projects are researched and developed over long time spans, measured in scales that consist of years rather than weeks or months. A dominant conceptual thread in my work over the past 2 decades has been to unravel the foundations of anthropocentrism or human exceptionalism by investigating the interstices of myth, metaphor, and epistemology, where scientific knowledge and research allow us to question commonly held assumptions and beliefs. To accomplish this work, I have built relationships with scientists and other researchers engaged in exploratory and field research, shared laboratories, and now work in a newly built science wet lab. So for this lecture, I'm going to try to squeeze about 6 lectures into one, and hopefully it'll make sense to everyone. So I'll start with I guess, a simple question, maybe not. Where do we come from and how did life begin? Does all life come from previous life, or is there spontaneous generation of life? Is life special, or is there nothing special about life at all? Can life start from a point of origin? And what is the difference between alive and dead matter? The historical, philosophical, and scientific debate about how life began has ensued for centuries. Further, the dualistic argument between vitalism and deterministic materialism view on the origins of life have shaped our thinking throughout the centuries, resulting in the creation of artificial distinctions between ideas such as organic and inorganic, alive and dead, and human and non-human. I attempt to analyze this debate through the agency of matter itself. Historically, the vitalists of the 20th century believed that life consisted of something special or unique that existed outside of the material world and could not be found by taking a living thing apart, or known as holism, while the mechanists believed that life could be explained by physiochemical processes that were deterministic, mechanistic, and could be understood from the study of its parts. Is there a middle ground or paradigm that does not make such distinctions? Is there a model that takes into account this emergent process of complexity, energy, materiality, and evolution? So to start thinking about this question, I'm going to look a little bit at history. And so this is von Leeuwenhoek from 1674, who is the inventor of the microscope, and also a stand-in drummer for Tommy Lee Jones of Motley Crue. So how did life begin? Was it spontaneous generation? In this case, it was posed that there was something called epigenesis and preformation, which were persistent ways of describing and seeking to explain the development of individual organic form. Does every individual start from material that is unformed and the form emerges only gradually over time? Or does it start in some already preformed or pre-delineated state? And you can see here in this image, we have the first drawings, which I assume are probably E. coli or bacteria. And then you have the preformation of a little person inside of, in this case, a sperm. And that it was only thought at that point that the uterus was only a place to house and grow the developing person that was already inside of the sperm. And then in 1859, Louis Pasteur put this debate about spontaneous generation to sleep, essentially by doing an experiment, which I redid the lab so you can get an idea of what the experiment existed of. And we have 2 flasks. One is the control with a straight tube on the top, and then the gooseneck on the right is the other tube. And what happened is they put in chicken stock or a beef stock into the flask, boiled it for 30 minutes, and then capped it up. And what was determined is that the flask that has the gooseneck, the material inside of it would not spoil because bacteria could not get in, right? That was the prediction, right? That bacteria is what was causing things to spoil, and that life didn't just spontaneously come out of the solution in the flask. And then of course, in the control one on the left, with the straight straw, bacteria was able to get in, and then the material spoiled. And then Stanley Miller made a famous experiment in the 1950s, which was the first step toward creating a self-evolving system where he filled an apparatus with hydrogen, methane, and ammonia gas in the presence of water vapor, and then subjected these to repetitive lightning like electrical charges. Within days, Miller was able to produce amino acids, which are key chemical constituents of the proteins that are key to life. So essentially, this showed that indeed life can form from the molecular beginnings, and the building blocks at least could be formed that would be the constituents of life. And then in 2008, Miller died, and we realized that there was so much more that could be done with this experiment and this inquiry, which really hadn't really progressed since 1950s. So I was sad that he died, but happy that it was something that we could take over as a piece. Which turned into Origins of Life Experiment 1.x. We transformed the Miller experiment into an open source performative reenactment called Origins of Life. We added the means to resupply the system with fresh gases, which Miller hadn't done, and water and minerals, so as to overpopulate the chemical species in the system. The overpopulation drove the chemical synthesis in new directions, so that we were able to obtain not only amino acids, but sugars, fatty acids, lipids, and even nucleic bases like ATP, and the entire range of basically the entire range of chemical compounds required to build the constituents of a cell. And this was the first setup. And you can see from left to right, there's hydrogen, methane, and anhydrous ammonia, which is basically creating this kind of aquarium on steroids that mimic the conditions of an Earth without life. Inside the flask, there is water that's boiling, and then it circulates with convection, and a lightning strike happens in the flask itself, and then it runs through the condenser, and then it cycles over and over again. There's another image. So the piece probes a historical, philosophical, and scientific debate about origins of life and the dualistic argument between vitalism and mechanistic or deterministic materialism view of the workings of life. And you can see these are little splatters of what Carl Sagan predicted as being called tholin, which are sort of the building blocks, part of the building blocks of life. So we were able to essentially recreate the experiment and then add to it. After cycling the experiment, we were able to drive and produce more and more different types of molecules and peptides and compounds. And then we realized that there was kind of a sticking point, that we needed to be able to go further. So this turned into rebiogenesis, which is a more complicated version. And so this will give you kind of an idea, just as a schematic, of the various components. I'll go through and explain what's happening in this too. But you can still see the gases from left to right as it was before. You have a control center for the gases, and then various flasks that are sealed in anaerobic conditions that could potentially generate different molecules. So a system that can evolve by means of natural selection must integrate 5 processes. The first is a means of creating variations among the elements of the system. The second is the overproduction of these elements so that not all can survive. The third is a way to non-randomly select among the variations so that those elements that do survive have a different distribution than the elements that were originally present. Fourth is a method to reproduce the surviving variants. And finally, this process must be able to be reiterated over and over and over again so that the elements are modified with each passing generation. Meaning there has to be enough variation, enough chances for different kinds of things to happen, right? So you can imagine molecules that are sort of floating around the space, and there's energy sources that act on those molecules. Some of them drive things together, some of them break things apart, and like electricity or heat can sort of vibrate these molecules so they join together and create new structures. So you have freezing and thawing cycles starting at the top left. You have ultraviolet light, which kind of simulates day and night. And of course, you know, if you have too much sunlight, you can end up with cancer because it's actually vibrating the cells apart and deconstructing DNA. Then you have heating and drying cycles. And then the electrical strikes here, which you can see then make a spark of lightning inside of the flask. And essentially this is this device is called a Marx Generator. And it was one of the circuits used to detonate the first atomic bomb, because you're able to pulse about 120,000 volts at pretty much unlimited current, and all based from a 12-volt battery, which I can explain over a drink later. So this interest in looking for how life began led me to start thinking about what are the earliest organisms that were on a planet in anaerobic condition, a condition without oxygen. And that led me to think about the piece called The Great Work of the Metal Lover, which is a neo-alchemical artwork that solves the ancient problem of the philosopher's stone, or the transmutation of base materials into gold using modern molecular and microbiological practice. So at one point, we were looking at a printout or a story in the BBC News about a black smoker, which down this deep in the ocean, which are miles down, there is no more oxygen. And we noticed that there are particles of gold that were on the surface of the black smoker, which to me indicated that it must have a biological origin in order to do that. So following this interest in understanding how life began, I turned my attention to organisms that were probably the earliest life forms on Earth. These extremophilic microorganisms were organisms discovered on Earth that have evolved within environments that were once thought to be uninhabitable to life. These extremophiles have adapted to thrive in environments of intense heat, acidity, salt, high concentrations of heavy metal, and have been discovered everywhere from hydrogen sulfide powered hot springs to these deep sea vents. And another realization was that the oceans are filled with about 10 parts per million of dissolved gold. We often think about gold as being a solid form, but it has an ionic form that can be dissolved and combined with chloride or fluoride or something else such as that. And so if you were able to actually harvest all the gold from the oceans, that would be an enormous sum. In fact, the Nazis tried to do that unsuccessfully during and before World War II. Using a bioremediation process with an extremophilic bacteria, and this was done in collaboration with a microbiologist, Dr. Kazim Keshefi, who is an expert in extremophilic organisms. The Great Work of the Metal Lover is an artwork that sits at the intersection of bioremediation and alchemy, re-examining the problem of transmutation through the use of modern microbiological practice, and thus solves the unobtainable ancient human riddle of transmutation of gold. Gold production is accomplished by the pairing of a highly specialized metallotolerant extremophilic bacterium named Cupriovitis metallidurans and engineered atmosphere contained within a customized alchemical bioreactor. The extreme minimal ecosystem within the reactor forces the bacteria to metabolize high concentrations of, in this case, toxic gold chloride, turning soluble gold into usable 24-karat gold. Through a reduced artificial anthropogenic environment, the liquid medium is purified by a collaboration with a colony of living bacteria. Thus, the unachievable goal of the magnum opus is solved not by human genius alone, but by the collaboration with another species. So what led me to find Kaz Kasheffi was he wrote a paper on hyperthermophiles and the reduction of iron and gold in 2000, which led me to think that it's possible to be able to do this process. And I asked him, do you think it's possible to be able to run a reactor so that we could produce enough gold during an exhibition where you could put it in the palm of your hand? And that was sort of the beginning of our collaboration to figure out if we could do that and do the work to make that happen. So we had to find, to do this kind of process, we had to find an organism that was not only able to reduce the gold chloride, so it had to be an extremophile, so it had to be a metallotolerant chemolithotrope, meaning it gets its energy from chemicals instead of like the sun or something else. And it also had to be mesophilic, which means it had to be able to grow in the kind of temperatures that we're accustomed to, like in a gallery space. So we set off to try to culture this organism, or Cupriovitis, and then we conditioned it over time to grow in higher and higher concentrations of gold chloride, just through like sort of slow selective evolution. And sure enough, we were able to get it up to between 2 and 4 millimolar concentration, which is a very high concentration. And then this is an image that shows through a backscatter mode on a scanning electron microscope, the deposits, which on here are white, of the gold on the exopolysaccharide formation, or the biofilm. So if anyone's ever had their teeth cleaned before and they have to scrape at your teeth, they're removing a biofilm. So you know how hard and strong those things are. And then of course the dentist, says something like, your gums are bleeding. I'm like, yeah, that's because you're scraping with a really sharp object in my gums. What do you think was going to happen? So you can see here's the peak. AU, of course, is the symbol for gold, and so we know we're getting that within the mix. So now the next thing we set out to do is to create a reactor that would be able to do this. And so this is the reactor setup. Everything is gold plated and designed around the ideas of the Philosopher's Stone, squaring the circle. There's some of the biofilm with nano deposits of gold forming at the bottom here. And it so happens that the original alchemists would describe the process as working when you had a purple color. And sure enough, we were getting a purple color while this reactor was running. And then after about 2 weeks, we had between 100 and 150 milligrams of gold, where you can see a nugget where sure enough, you can put it in the palm of your hand. And then this is in the scanning electron microscope. Once again, using the EDX analysis, we're able to show the deposits, which you can see are the little white spots. And then I used the old techniques, the ancient techniques of illumination, where gold is added to the surface of a print or a book. I'm using a Sodal compound, which is like a rabbit glue. And the prints function conceptually to provide objective proof that the claims of gold production are indeed authentic. and act as a literal manifestation of combining ancient practice with modern scientific imaging. And you can see this is the way you would apply the gold is through a straw where you'd actually breathe, and that would activate the glue. And then you take, once you it gets tacky, you take a little piece of gold and then place it on the surface and then brush it off very carefully after it's on there. And you can sort of see the process of where I'm doing that. And you have to be very patient with this process, especially if you have like more than 1,000 spots that you have to cover up. And then here's an image where you can sort of see the prints coated with the various gold in the locations indicated by the scanning electron microscope. So the next project I'll talk about is Irreverent Miracles on Demand. This is one of the more recent ones. And for centuries, the great monotheistic religions such as Catholicism proliferated stories about autonomous human mastery over all other organisms. Touting that man was made in God's image has blinded us to the fact that we are indeed interconnected to nature and that our histories have been influenced by non-human species. Irreverent is an artwork that examines the impact of invisible microbial agents on the course of human history and belief systems. Specifically, this artwork creates a miracle employing Serratia marcescens, a microorganism that grows on bread and creates a viscous fluid called prodigiosin that creates an uncanny resemblance to blood. Countless historical accounts of blood flowing from bread were recorded during the classical period of antiquity, the Middle Ages, as well as in modern times. Blood miracles were used as a complex anthropogenic currency to justify everything from corrupt human conquest and evidence of divine agency to anti-Semitic persecution, or known as blood libel. So here, this is a more recent evidence of a blood miracle recorded in November 24th, 2009, and registered with the Vatican as being authentic. And so you can see the host that seems to be spontaneously bleeding in the mouth of this woman. And this is a video I'll show you from your hometown, Buffalo.
Monica Fitzgibbons is up next, but first some news to tell you about. This week we received reports from a parish in the Diocese of Buffalo, New York, that may indicate a supernatural event involving a consecrated host. Diocesan leadership has apparently declined to investigate the matter further. Now, the Church has a long history of investigating Eucharistic miracles or purported miracles. In 1996, while an auxiliary bishop in Buenos Aires, Jorge Bergoglio, now Pope Francis, ordered photographs and analysis of a consecrated host that appeared to be bleeding. In the end, that analysis determined that the bloody host was actually human heart muscle. And as recently as 2015, here in the United States, the Diocese of Salt Lake City investigated a similar phenomenon where a consecrated host was bleeding. In that case, what witnesses thought to be blood was actually mold. Now, Eucharistic miracles are rare, but they do occur, at times bringing a renewed devotion to the real presence of Christ, the Catholic teaching that the consecrated host is not a symbol, but Christ truly present, body, soul, and divinity. Joining me now is an eyewitness and a former parishioner at the parish where this all happened, at St. Vincent de Paul Parish in Springbrook, New York, in the embattled Diocese of Buffalo. Lisa Benzer is the Director of Religious Education, and Mike Bentz is a theologian and former parishioner. Thank you both for being here. Now, as I understand it, in mid-November, a host was inadvertently dropped on the ground at Mass, and a church deacon placed it in a receptacle in water to be properly disposed of later. Then on Friday, November 30th, the Eucharistic minister noticed something unusual about the host, and we have the image up now. Lisa, you were among the first eyewitnesses. What did you see here, and what did you think?
Just to clarify, I was there about 15 to 20 minutes after the Eucharistic miracle happened. So, but I will tell you my account. So Father Carl had the Eucharist in the ablution cup, and in the ablution cup was it was where Jesus was. And so I went to the rectory and I actually saw Jesus at that time, what I thought was Jesus. There was a presence there. And I instantly, when I saw him, I kneeled down to the ground and I was in awe.
Just to continue on, as much as it's fun to watch that. So a miracle is an event that is not explicable by natural or scientific laws and is therefore considered to be the work of a divine agent. And this is a quote here by Baruch Spinoza, a 17th century philosopher. And he says, as nothing happens in nature which does not follow from her laws, and as her laws embrace everything conceived by the divine intellect, and lastly, as nature preserves a fixed and immutable order, it most clearly follows that miracles are only intelligible as in relation to human opinions and merely mean events of which the natural cause cannot be explained by a reference to any ordinary occurrence, either by us or at any rate by the writer and narrator of the miracle. And I like the way he talks about this. And according to Spinoza, just to paraphrase, miracles are not a transgression of natural and scientific laws, but rather miracles are events that reveal epistemological gaps in our knowledge. In other words, miracles are events that surpass our limited human comprehension. Moreover, nothing would appear miraculous if we had a perfect understanding of the laws of nature. So to go back in history in terms of blood miracles that have been recorded, at least, and documented historically, the first is over 2,000 years ago. The ancient Phoenician, now Lebanon, city of Tyre was a thriving commercial center featuring a prominent Mediterranean harbor. The island city, located a half-mile from the Phoenician shore, was heavily fortified, surrounded by massive defensive walls, making it a key naval base. In 322 BC, when Alexander the Great, on his famous march, was denied entry to Tyre, he decided to besiege the city. And there's that was the equivalent of a Polaroid of Alexander in 322 BC, and the only image I could find. The Macedonians under Alexander worked for 7 months to build a causeway to the island from the mainland so that their catapults could breach the walls. The weary Macedonians, laboring to finish the causeway under a constant rain of arrows and stone balls, were going to give up if it were not for an omen. When the Macedonian soldiers broke bread, drops of blood trickled out and dripped onto the floor. The presence of blood was read as an omen, prophesizing the destruction of Tyre. There's in the 1920s what Tyre looks like from an aerial shot. So Quintus Curtius Rufus, the Roman historian in the history of Alexander the Great, written in the 1st century, elaborates, and he says that basically recounts this episode of when blood was seen to flow out and fall onto the boots, which then emboldened the soldiers to besiege the city. The Macedonians completed the causeway, captured Phoenician ships, stormed Tyre, killed 8,000 Tyrians, and sold another 30,000 into slavery, and left the city for ruin. This is just one example of many reported throughout antiquity, citing the miraculous appearance of blood on food. And many microbiologists agree that it's likely the appearance of blood, or at least in part, was due to this microorganism invisible to the eye, named Serratia marcescens. And this is an image in 2013, again, all from a bacterium masquerading as blood. Another example, countless historical accounts of blood flowing from Eucharist bread were recorded during the Middle Ages. Starchy host bread within the damp walls of the medieval churches must have made an excellent incubator. In the Church of the Holy Christina, as the priest was blessing the elements of Holy Communion at the same time, doubting the truth of the transubstantiation, or the turning of bread and wine into the body and blood of Jesus, drops of blood fell onto the linen robe. He attempted to hide his spots by folding his robe, which caused more bloody figures in the host to appear. And then, of course, this image is painted by Raphael commemorating the event in a fresco in the Vatican titled the Mass of Bolsena in 1508. An alleged desecration of the host by Jews in Sternberg, Germany in 1492. As a result, 26 were burned, and this was commemorated in a German woodcut. So a myth was spread about the Jewish community and reports of blood on communion wafers. In Germany, a woman removed a consecrated wafer from her mouth and sold it to Jews who stabbed the host, causing it to bleed. Similar reports of bloody communion wafers may have served as a basis for the persecution and execution of Jews for more than 200 years. Bleeding hosts were used as a cultural currency and proof of the transubstantiation of Christ. And you must admit that it's remarkably similar to the current day conspiracy theories of QAnon and what is being talked about with the Clintons and children's blood and Judaism. So it hasn't really disappeared. To research where these events took place, I took a trip to Austria in a library called Gottweig Abbey, and met with Father Gregor, who is the basically the curator of this collection, which has still to this day, as far as I know, not been digitized, but it has many accounts that talk about these various blood miracles, which led me to a place called Polk Church of Holy Blood. And in the main altarpiece in 1338, there's a commemoration of an event that took place there. So I somehow was able to talk my way into flying a drone in the church over about an hour and a half period. And they acquiesced and let me do it. And the whole time I was terrified that I was going to crash this this machine into the walls of the church. And the first, and I'll tell you the story of what happened there over this video. The first is an event, a terrible but all too common type of 14th century event, the massacre of Polk's Jewish community on April 23rd, 1338. According to several Austrian and Bohemian chroniclers, on that day, a crowd had gathered in the town center in response to rumors that a desecrated host had been found on the doorstep of a local Jew. Passions, we are to infer, flared into violence, and most, possibly all of the town's Jews, numbering about 150 persons, were seized, brutalized, and massacred, and their possessions plundered. And you can see on the altarpiece on the left side, there's a Jew stabbing the bread or the host, and then on the other side, on the right side, trying to hide the evidence in a nearby stream. I have a close-up of that image, which is that one. Give you a better look at it. Reports indicate that victims were burned alive and reduced to dust. Some of the victims, unable to flee from their persecutors, committed ritual suicide in order to avoid forced baptism. And to me, it's pretty amazing that it's actually commemorated inside of a church, this event. So this is Serratia marcescens on scanning electron microscopes. And now I'm going to sort of shift into the lab work in order to sort of create our own blood miracles. And on the left side, you can see many cells and the prodigiosin, which is the blood-like material at high magnification. And to the right is a single, very typical bacterium of Serratia marcescens. So we started by trying to create essentially blood miracles ourselves inside of the lab using the same materials that were purported throughout antiquity. And so this was our first try at it. This is my assistant, Drew. And we were able to get some bleeding happening inside of the bread itself. So we basically injected the bacterium into the bread, and that was what we found after incubating after a couple of days. And then we started making our own Eucharist bread, and this is a time lapse over a 48-hour period. And so you can see the inoculation starts devouring, the bacterium devours the bread. And as the carbon source is rich, it starts producing this simulated blood material. And the longer it sits, the gooier it gets and the more convincing of blood or a scab it is. And then this is, I purchased a Eucharist bread maker from Rome. And then we put that in the lab, and you can sort of see it's kind of like a giant waffle press, but very thin.
I can't really tell anymore.
Gets squeezed down, and we were making our own Eucharist bread. And it seems like this would be a fairly simple activity that you get the bacteria and then you place it on bread and it would work, but that unfortunately wasn't the case. And there was a bunch of experimentation trying to figure out what the pH levels needed to be, and it turned out that it likes basic water. It's like around a pH of 8 to get the color to show up in the way that it does. Yeah. And which would make sense because chances are well water, which would be used at the time, would be more basic than acidic. And we're cutting out the Eucharist bread there. I'm going to keep moving here just to stay on course, which then, so physically the installation consists of a bioincubator inspired by medieval Roman Catholic monstrances. A Eucharist host is placed in the oculus, which is the glass area, meaning to look at. The microdroplets of media containing the strain of S. marcescens are delivered to the bioincubator, and over the course of 2 days, the inoculated hosts incubate the organism, causing the bread wafer to bleed, thus producing a blood miracle on demand, similar to those seen in churches centuries ago. The installation intends to destabilize human exceptionalism by questioning how human entanglements with other species shape our history, stories, and myths, and therefore redefine our ontological status. And you can see this is the portable case to the right, where everything goes away and is transported. And you can see the monstrance itself is made out of Teflon material, because not even Jesus sticks to Teflon. And the reason that we're using materials like Teflon and glass and stainless steel is because it's the indexical materials of our time, the indexical materials of a laboratory. And in medieval times, it was very common to use materials that were more than just what they look like, but actually had powers based on the materials and the qualities that they carried with them. And the right, this is the reactor inside of the pedestal that you saw, where it's growing and incubating the organism, getting ready to drip onto the surface of the bread. Here's a really bloody one that grew for a long time. This was in Japan just recently, about a month ago. And then this is an image behind the pedestal, kind of looking under the hood, so to speak, where you can see the bio incubator, the chemostat, peristaltic pumps, mixers, and other materials needed to produce the miracle. So the final project I'm going to talk about is a project called Shadows from the Walls of Death, Bioremediating Greenness. This is one that's still sort of in process, but I thought I'd show you something that isn't completed so you can get more of an idea of what goes into these projects. So the Industrial Revolution of the 18th and 19th centuries gave rise to modern cities, removing humans from an entangled connection with nature. A growing body of genetic, physiological, and psychological evidence suggests that humans have evolved biologically and culturally to be attracted to greenness. Shadows from the Walls of Death explores the paradox that the further we removed ourselves from nature via urbanization, science, and technological development, the more we tried to connect with it and the more our means of connecting led to its destruction. It seems that our need for green was so strong that during the height of the Industrial Revolution, we mass-produced arsenic-laden synthetic green pigments that were used by artists in garments, in printed wallpaper, and even as a colorant for candy. The very chemical processes artificially employed to bring greenness back into people's lives helped to contribute to the anthropogenic destruction of the environment, poisoning painters and patrons of the arts alike. Separating, containing, and pacifying nature has been an ancient pursuit of man. For millennia, Homo sapiens have slowly been trying to extract themselves from the natural order. Myths and parables from Judeo-Christian tradition, and more specifically Christianity in the Western world, spiritually embolden Homo sapiens to conceptualize nature as a teleological entity designed for us to control and consume. In the West, the moral superiority of man over nature resulting from the so-called natural philosophy led to the rise of sciences and technologies that set the stage for the Industrial Revolution. The growth of modern industry and factories beginning in Europe during the Industrial Revolution resulted in the massive urbanization giving rise to modern cities. New opportunities attracted multitudes of migrants, and as cities rapidly expanded to accommodate the new migrant workforce, buildings were constructed, brick and mortar, concrete, and factories replaced grasses, leafy plants, fruit-bearing trees, and vegetation and soil, or green space as we would talk about it today, isolating us from the natural ecology from which we evolved. Natural resources were being stripped and the landscape along with it. For example, England had removed 90% of its original woodlands by the 1700s. The economy shifted from an agricultural to an industry, forcing the average person off the land and into the cities. The growth in population in 19th century cities moved at such a rapid pace that there was not enough capital to keep up with the housing, and low-income newcomers moved into overcrowded slums. In 1845, in the now well-known comprehensive report and critique, Condition of the Working Class in England, social activist and co-author of Marxist theory, Friedrich Engels, describes the condition of the proletariat in the towns surrounding Manchester, and said the towns themselves are badly and irregularly built, with foul courts, lanes, and back alleys, reeking of coal smoke and especially dingy from the original bright red brick that had turned black with time. Is here the universal building material. City planners, with occasional exceptions such as Frederick Olmsted, who designed Central Park for New York City, gave little forethought for our human desire for green space. Our affinity for greenness or chlorophilia probably began around 30 to 45 million years ago, when humans evolved full color vision, including the ability to perceive the color green. Countless studies have indicated that humans need access to green space to reduce stress and be healthy. We appear to crave green, or at the very least have associated the color green with nature, health, and wellness. Building on the new concrete and steel urban environment beginning during the Industrial Revolution resulted in landscapes of brown and gray, evolutionary equivalents of winter and death. Color associations are not fixed symbols, but are tied to cultural and linguistic associations, as well as to the material world. Symbolic associations of chance, money, and love were likely due to the historically unstable chemical properties of green paint and dyes. Throughout Western history, green has had dichotomous meanings, a symbol of life, luck, and fertility and hope on the one hand, and a symbol of poison, disorder, and the devil on the other. Current symbolic associations with green, one being connected to nature, health, sustainability, and ecology, grew out of the Industrial Revolution. Amateur gardening and corresponding magazines developed a mass appeal. This was no more apparent than during the Victorian fern craze of pterodomania. The fern craze was made possible due to an invention developed by an amateur botanist and naturalist, Dr. Nathaniel Ward. For years, Ward had unsuccessfully been trying to cultivate ferns in his London home. Like most cities' backyards, his home was surrounded by factories producing soot and toxic fumes that killed his plants. In 1829, in a moment of despair, he made an accidental discovery when a fern spore sprouted in a wet enclosed container in which he was growing moss. Ward realized that the noxious gases from the manufactories were destructive to the health of the plants in the city. The ferns in enclosed glass cases were able to thrive due to the fact that they were isolated away from the toxic anthropogenic environment induced by industry. Ward went on to cultivate more than 100 species of ferns in enclosed containers and eventually experimented with glazed glass cases that became known as Wardian cases. These cases delivered contained and tamed nature back into Victorian homes, as well as supported colonial interests by aiding transportation of plants across the world. Further evidence of the desire for green was the development of green spaces, botanical gardens, and parks beginning in the early 1800s. The Industrial Revolution also marked the beginning of modern chemistry. And with modern chemistry came bright prismatic synthetic pigments such as Scheele's green in Paris or Schweinfurt green. Until the 19th century, painters, fabric dyers, and other artists were generally limited to the range of colors they could use to naturally occurring pigments found in minerals, plants, and insects, squid and octopus ink, and so forth. Now, for the first time, chemists were learning how to make pigments that nature never produced without humans. New green pigments were particularly valuable because the range of green colors available prior to the 19th century was limited to those that were either expensive, such as malachite, earth greens, which covered badly, or unstable plant greens, such as leek juice, were corrosive and reacted with neighboring colors, such as verdigris and copper resonate. Entrepreneurs suddenly found that there was a strong desire among the public not only to bring living plants to the home and build public green space, but also to make green a fashionable color. Scheele's and later Paris green were used as a colorant for candy, dyed clothing, and other fashionable accoutrements. Gas lighting replaced candles during the revolution, increasing lighting in living quarters and made it possible to use darker materials on the walls of homes. The rich colors of these new synthesized green pigments were printed on wallpapers and applied to walls, probably very similar to the background of this Van Gogh. One of the most popular green pigments invented in 1775 by Carl Scheele. Like many of these new synthetic pigments, Scheele's green, as it was known, was composed of heavy metals that turned out to be highly toxic due to the fact that the primary ingredient of the pigment was arsenic. While arsenic has been proven to have some useful properties, such as medicine to treat syphilis before antibiotics, a beauty agent that whitens the complexion of European women, and a highly effective insecticide, its poisonous quality should not be underestimated. In 1874, Dr. Robert Kedzie, a professor of chemistry at Michigan State University, where I am based, wrote a book titled Shadows from the Walls of Death, also where the title of this project comes from. In an effort to raise public awareness from the dangers of arsenic pigmented wallpaper, 100 copies were sent to public libraries across the state of Michigan. Each book consisted of a title page, preface, 86 wallpaper samples taken from common merchants, and a note from the Board of Health warning librarians not to let children handle the book. In the preface of the book, Kedzie outlined the effects of slow chronic arsenical poisoning. Most of the 100 books were destroyed because of the danger they posed to the reader. Now only 3 remain, and one of those copies happens to be at Michigan State University. The other's in the National Library of Medicine, and still another, which I haven't been able to locate, is at the University of Michigan. Dr. Kedzie described the effects and dangers of the arsenic pigmented papers. Over time, the wallpaper is exposed to varying environmental conditions like heat and cold and moisture and dryness broke down, dislodging microscopic particles of arsenic dust. As the suspended arsenic dust is inhaled, it enters the lining of the nasal cavities or the mucous lining of the lungs, and symptoms quickly appear, which often made people feel, sounds like they had COVID, was a very similar type of response. And oftentimes people would actually die in their sleep being in their bedrooms. There's one theory that that's how Napoleon died, from being surrounded by arsenic wallpaper in St. Helena in the middle of the Atlantic on the equator. The enormous distribution of these fashionably green wallpapers across Europe, and an estimated 65% of wallpapers in the United States, it's not surprising that many fatal accidents occurred in children's bedrooms. Arsenic poisoning in green factories that annually produce as much as 200 tons of cupric arsenic was also well documented. Workers suffered considerable symptoms of arsenic poisoning, conjunctivitis, anemia, lesions, scars, ulcers on the hands, legs, face, and genitalia. The technological innovation of new bright, prismatic, and less expensive synthetic pigments, coupled with new scientific understanding of color and light, gave rise to a new rebellious and conceptual artist at the end of the 19th century. Painters moved away from the traditional subject matter of Greek myths and royalty and idealized forms and began painting everyday people, urban landscapes, and the countryside. The invention of tin tubes in 1841 by John Rand, an American, allowed the long-term storage of prepackaged paints and increased portability. Now the painter could work in the midst of his subject, which was often nature itself. Impressionists were trying to capture firsthand the reality of light and color from the real world. A growing middle class could afford to buy these impressions of nature to bring greenness into their drab urban homes. Many ironies inherent in the means by which painters strove to bring nature, and in particular greenness, into urban settings. By painting in plein air for the first time, artists simultaneously lost touch with the materiality of producing their own paints. Paint manufacturing by means of chemical synthesis permitted mass production and distribution of pigments that separated the painter from his or her direct sensual experience of grinding solid pigments and natural materials into soluble paints. Thus, the increased convenience and commercialization of these new artist supplies separated the painter from the material world, from which painting itself had evolved. Additionally, painters, including impressionists, used these mass-produced toxic pigments to portray the very nature that the Industrial Revolution was eroding. Thus, the human drive to recreate greenness within cities led to a series of paradoxes and contradictions. The very chemical processes artificially employed to bring greenness back in people's lives helped to contribute to the anthropogenic destruction of our environment, which clearly continues on till today. And the further we removed ourselves from nature, the more we tried to connect with it, and the more our means of connecting led to our destruction and is leading to our destruction. So in the lab, the first thing that we worked on was, since you can't purchase Scheele's green or Paris green any longer, we went to work at synthesizing it ourselves in the environment of a chemical hood with safety gear. And so you can see we finally got Scheele's green correct. You can sort of see here are the pigment crystals and the X-ray crystallography verifying it against a database that sure enough, this was Scheele's green. And then also the synthesis of Paris green, which you can see here is the formula, although that doesn't really tell you how to produce it exactly. But this is a cupric acidoarsenite, which the arsenite is the more volatile form of arsenic, so it absorbs into the body very easily. And so in a chemically safe and controlled environment, the greens are made from scratch, reestablishing the painter's material connecting to his paints. These paints will then be used to produce impressionist plein air paintings. There is one of the crystals magnified. And then this turned into the artwork of shadows, the performance shadows from the Walls of Death, which you can see here. This is presented in Riga. And the performance series and installation Shadows from the Walls of Death further develops my focus on how chemistry and microbes mediate the human experience of nature, questioning anthropocentrism, and address the emergence of the Anthropocene. With its title drawn from the writings of the late MSU chemist Robert Kedzie, Shadows deconstructs the symbolic and superficial use of green as a masquerade, supposedly synonymous with ecological and vegetal health. In fact, the first true green pigments were highly toxic carboacidic compounds called Paris green and Scheele's green. These were developed during the 19th century, employed by the Impressionists, and also used once again for pigments for candies, clothing, and wallpaper, which we've seen. And then you can see this, I'm in a chemical tent in my hazmat suit with the actual pigment that I'm producing, as the performance is more or less a cooking show for how to produce your own toxic pigments. And thus bringing the green of nature indoors actually resulted in the poisoning of people and their environment they wanted to create. And we're actually recreating some of the wallpapers by hand that were found in Kedzy's book, Shadows from the Walls of Death, and thus reestablishing, ironically, the artist's material connection to the production of pigments while simultaneously undermining the natural, quote unquote, meaning of the color green. And then finally, in further development of Shadows of the Walls of Death, the green window in the Van Gogh painting titled Bedroom in Arles is copied in a petri dish using the Paris green pigment that we produce. As such, the painting is then inoculated with a bacterial ecology that then attempts to bioremediate and detoxify the painting. Microecologies capable of detoxifying arsenic exist due to the evolutionary principle. Everything is everywhere the environment selects. Here, these non-human microecologies not only help us out of this toxic environmental predicament, but also deconstruct ontologies based only on human dominance. So this project, we're currently working with finding ecologies of microbes combined with fungi that are able to remediate and store and remove the toxins from these paintings. And the organism that we inoculated this dish was Herminomonas arseno-oxidans. And it did work, but it took an extremely long period of time. And unfortunately, I don't have an image of that. So that's pretty much the end of the slides that I have for you. I think I got just in an hour, but I wanted to talk really briefly just before concluding. And that's today more than ever, myths and metaphors and words matter, right? These cultural artifacts shape how we think about and understand the world around us. Words are not just simply empty vessels, but they carry baggage. For instance, enthusiasm, if we look at the etymology of enthusiasm, the word means literally to be possessed by God. And that we don't even have autonomy over our own beings, but God is somehow directing us. And all these words are embedded into our language in such a way that we don't even realize what they carry with them, and they still exist. Inspire, which is another word where its Greek etymology is a divine or supernatural being which will implant a truth or idea into someone. You'll be taken over by a supernatural being because you're not capable of having that kind of inspiration. And finally, goodbye is short for God be with ye. So every time you say goodbye, you're recalling our colonial Christian ancestors. Anchoring, so how do we get rid of these things? Well, there's something called anchoring bias. It's a cognitive bias that causes us to rely too heavily on the first piece of information that we're given about a topic. When we are setting plans or making estimates about something, we interpret newer information from the reference point of our anchor instead of seeing it objectively. So what I encourage you to do is that I encourage you while you're in school, for the students here and everyone else, is that not to hear the first thing not to take the first thing that we hear about a subject and take it as being truth, but to seek truth beyond that point. And the glimmer of hope is that we can overcome our evolutionary predicament via something called reason. And the human's ability to be able to reason is one of the most underestimated, in my mind, components of what we're able to do. And if we can reason, we can surely get our way out of this predicament of global destruction. So if we can acknowledge our biases, we can consciously seek truth. And with that, I say goodbye. So 1 hour.
Adam, thanks very much for that terrific talk. And at this point in the evening, I just invite you all to activate your mics and speak up and announce yourself and take the opportunity to speak directly with Adam.
Hello, am I speaking?
Yes, Austin.
Hi. Hi, Adam. I love your work, by the way. It was very intriguing. But I have a question in reference to your alchemically themed work. I hope you've come across Carl Jung, specifically his book, Psychology and Alchemy.
Yeah.
Nice.
He was one of Freud's students,
Yeah.
right?
Yeah, he was. I have yet to read that book, but I've read Man and His Symbols. And I wanted to know what your thoughts on, as much as I've loved your like play in like the themes of alchemical like tradition, because there were like chemistry based stuff present there in like that time period. My question is, Jung's beliefs were more centered around the fact that alchemy was a extension of Christian mysticism, which I'm trying to phrase it properly, sorry. An extension of Christian mysticism that kind of just fell short, where it was just playing with these collective unconscious ideas without actually recognizing that we are in that kind of ness, without actually like, being as, I don't know, up to date as your modern like interpretations in science has like framed it.
Well, when Carl Jung wrote those texts, that was modern and contemporary at the time, right? And alchemy, while it did stem out of Christian and actually Islamic tradition, it wasn't Christian in the beginning, it was Islamic. It was really a proto-science at that point. We hadn't really worked out the full scientific method. We hadn't worked out that we needed to record the experiment that we did so it could be repeatable, right? That was never something. In fact, it was the opposite. Everything was cloaked in mystery and code. So someone wasn't able to do that. But what I appreciate about alchemy in general is that what it did, and it maybe doesn't do as much now, is that it was about not only trying to better yourself intellectually using reason, but it was also about bettering yourself as a human being, right? As being good to the world, as being a good person. And as an artist, I like sitting in that realm, but realizing that alchemy was a historical point, right? It was a place where a natural progression moving to the sciences where we're at now. In terms of the rest of what Carl Jung had to say, I mean, this is, in some ways, you know, I enjoy him, but he very much is a remnant of modernism, right? Of these sort of dichotomies that I'm fighting against. These man, woman, right? Life versus alive versus dead, right? Obviously, you know, there's much more to situations and understanding and epistemology than simple dichotomies, which in my mind sort of put us in the predicament that we're in now.
That makes a lot of sense. I've actually haven't gotten as deep as that, but yeah, I greatly appreciate that response. Briefly, I know that these are being recorded. It's just that there's so many details in this presentation. I was wondering where we might be able to find this recording again.
Well,
towards Maximilian, specifically Mr. Goldfarb, Professor Goldfarb.
Oh,
Sorry.
yeah, the recordings are part of the department's archive, so they're not circulated outside of UB, but you can talk to me at another time, and I can direct you towards how to search the archive.
And you can also go to my website too, which is not fully fleshed out yet, but there's quite a bit of information. There's video documents of the work and more information, so you can sort of look at it in more detail.
All right, thank you.
You're welcome.
I have a question. Well, more of like a wondering what you think about this. You were talking about the color green and how humans have this keen likeness towards it, and it got me thinking about money and wondering if maybe people made money green because, or just to push the consumerist agenda, just so humans have this like tendency to have it.
Oh, I wish it, I mean, that would be interesting if it was that deliberate. I don't know. That sounds like a good research question, actually, is, why is money green? I mean, it's not green everywhere. That's just our money, right? I mean, and even our money has changed color a little bit, not as much as some countries. And some countries are much more colorful. But I would imagine that there is a very good reason for the color that it is, probably so it's not able to be counterfeit. But yeah, I mean, it's possible, but my guess is I doubt it would be my hypothesis now, but maybe. But if you find out, let me know. I'd like to know the answer to that.
All right, thank you. I definitely will.
Thanks for your question.
Maybe I'll ask a question, Adam, if you don't mind. This is Paul. Yeah, can you hear me?
I can see you too.
Hi. Going off the last question, I thought I would ask a related question. What how is like research different as an artist than maybe for other fields, or like what makes, because you answered the last question with research, and I'm thinking there's something very particular about the way that you approach problems. It's probably different than the way a scientist would approach it, or even the way a historian would approach it. So I'm just wondering what do you think is similar or different, or how you do it?
Yeah, that's a great question. It's something I've been thinking about actually a little bit over the last containment in my home. And I do think it's different, but in many ways the same. The way that it's different, I think stems from the fact that our output is different. Yes, I do some writing and write, book chapters and essays here and there and give lectures about the work. But the completed vessel for me is not the paper, but the vessel of the research is the object, or the production of the artwork or performance or whatever it is. So I think maybe the translative end goal is what's different. And maybe that's what's different in terms of the research process. And maybe that also has like that sort of alchemical relationship as well, where you're trying to find out more about the so-called truth of what you're investigating, and then also trying to understand yourself while you're producing the work. So maybe there's like a different level of sort of emotional investment that maybe goes into it for the artist. I don't know. What do you think, Paul? Does that ring a bell for you at all, or because you're similar, you do similar kind of work?
I think a little bit. I mean, it just came up because I think I probably have a similar kind of way of approaching things to you. And I was also thinking and looking at in your talk that like maybe like even though they talk about all these new forms of like digital transistor memory for computers and stuff, it's like maybe artworks are actually like the most condensed form of keeping track of lots of facts and information, right? Like if you can just unpack these artworks, all these like kind of incredible stories are kind of all packed into them. And if you ask a question about why the material, you get a whole sort of flowing of information about that material or something. That maybe artworks are really these really condensed forms of like knowledge storage.
I like that. Yeah, what Paul said, that was a better answer.
I'll shut up now.
I appreciate that question / comment. I was also wondering maybe in relation to that, thinking about Intermedia, kind of the objectives of Intermedia, and this idea of kind of transmitting or resonating out from something that's like a rarefied language of one or another art discipline, but speaking across disciplines. I was thinking about the Blood Miracle project. Forget what the exact title, if I have the title right.
Irreverent.
And just like, I would imagine that that's something that, speaking to like a broad audience, there might be like resistance to your reshaping that narrative of interpretation. And you're using like aesthetics of the laboratory and objective research as a challenge to interpretation. And I guess I'm just curious about when your work, a project like that, leaves like the kind of the disciplines of art and enter into culture, if you kind of what kind of conversations happen there?
That's something that I've been very eager to explore. So far, the piece has really stayed in sort of a capital A art space. So you tend not to have maybe the collisions in those kinds of spaces like Ars Electronica or in Japan, that you would if it were to enter sort of a more real world situation. But I'm very anxious to sort of enter that space. Like, I'd love to see the work placed in a church. And the way that I also look at it too, or the way I talk about it, is that so I was raised through high school by Jesuits. I was in a Jesuit school, so I was very familiar with a Catholic upbringing. And I don't necessarily think that what it is that I'm doing necessarily contradicts the teachings of the church, depending on how you look at it. So for me, I guess what I'm saying is I'd really like to enter that kind of conversation. I intend for the work to challenge notions, or for people maybe even to question themselves and why they think that they're so great, that they're the chosen species on the planet. And that conversation is where the work intends to go, but I haven't so far, as it's a fairly new work, and then plus of the lockdown, I haven't had a chance to show it in that way.
Thank you. I know there are probably some other comments and questions looking at the chat here. Want to make sure everyone has the opportunity to speak up.
I have a question.
Okay.
How so your last work with the arsenic, I found it very interesting that you recreated these processes, and that, like, I've been getting a lot of like videos recommended to me of like Victorian killers. So I've been like watching a lot of videos on how dangerous like the common homes of that time really were. How would you go forward? Because you said this work isn't done, you're like in the process of still working through it. How would you display it besides just in that performance aspect? And can you safely like display this work?
Yeah, it's a great question. Yes, you can if you take precautions. And what I'm looking at now with this is, I sort of mentioned at the end, but it might not be clear, is working with various strains of bacteria and symbioses and ecologies of bacteria and fungi all working together, which they often do, in order to bioremediate the paint. And so the end goal that what I'd like to do, and we'll see if this happens, is to be able to recreate an impressionist painting and be able to put it into an incubator or a reactor that's specialized for the painting, where the painting could then be inoculated, or the organisms could be introduced to that painting within this enclosed space, and then actually bioremediate art history.
I look forward to seeing that. Thank you.
Yeah, me too. Any last questions?
Yeah, I have a question very quickly. Thank you again for sharing your work. It's super intriguing to see how we can go deep working with bacteria and other species. And my question is, because it's a question that I have also for myself working with bacteria, how you see these organisms or these other forms of life in your work, if they are just media or they are collaborators of your work. So yeah.
Yeah, I don't know how you could see them as anything other than collaborators, because as you know, Felipe, being a biologist yourself, you know that if you work with these organisms, they're almost like really detailed and work-oriented pets. It's like you couldn't drop off your cat in a space and expect it to be able to take care of itself. And these organisms require a lot of care and time and energy to make sure they stay alive, and that they work with you, or you can collaborate with that organism to do, in my case, the phenomena that I'm hoping to present. So they're very much alive, and it's not like most artworks. When you think about it, you know, you have this painting, you have this sculpture, you have this thing, you drop it off, you leave, and you're done, and you get it back some months later in a box, right, and then shipped back to you. You can't do that with any of this type of work. You have to consider, once you leave, if it's far away, who's going to take care of it? How are you going to communicate with that person about its care? So there's this whole cycle of interrelating and working and collaborating even with the space that you're showing this work in order to maintain the care of these organisms. So they're very much, for me, definitely not media. And I mean, I even get to the point when, you know, you're at the end of an exhibition and you generally have to autoclave the materials. And by autoclaving the materials, you're in a sense killing the colonies, killing billions that are inside of these vessels. And that's sort of something that I'm still not quite sure how I feel about.
Okay, thank you. Me either.
Okay, this is any last words? Anyone have any last questions? Well, Adam. Yeah, David.
Yeah. Hi. Yeah, I just wanted to ask, after doing all this research, one of the interesting topics that you talked about today, for me, one of the topics that stuck out to me the most was the beginning, where you were talking about your experimentation with trying to create the like the beginnings of life and trying to simulate that. Do you think trying to create those very meticulous details, and how you were just saying that these bacterium need very specific care and you need to take care of them and all that, do you think after doing all that research, maybe that could lead to you strengthening faith in a in like a religious way, where it's like all this stuff needed to be in a perfect way for it to happen, or all this stuff needed to be a certain way for anything to occur, that it's anything less or short of a miracle?
Well, again, I can't consider it a miracle because I can reproduce it. You know, by the very fact of being able to reproduce an experiment and get the same results, that implies that I have an understanding, that reason suggests that I understand how this process works because I can reproduce it. So I don't, and you know, there's also a difference, I think, too, between spiritual and religion, right? So religion is organized. It is a human construct, much like the YMCA or a school, you know, or the government. There's really not much difference. It's a simple construct. And with spiritual, like that's something that, like, where you feel like there's a connection to something that's bigger than yourself. And so in that regard, if I can substitute your word religion with being spiritual, is I do feel like there's a spiritual connection when you have an understanding, an ontological and epistemological understanding of how the world works, or how when you do experiments, you change the way that you see how the world works within each iteration, or even change your mind with how the world works. And to me, those things are extremely powerful and make me feel connected to everyone and the globe in general. And so, yeah, that's, I'll end it there.
Yeah, thank you. I think spiritual is actually a lot better word than using religion.
Yeah, me too.
Okay, well, thank you all for your questions. And of course, again, Adam, thank you so much for visiting us tonight, taking the time to present your work. It's contributed a great deal to our series. Yeah, thanks very much.
All right, thank you very much. And thanks everyone for sticking around and listening to the questions.
Okay.
Thank you.
Thank you.
Thanks. Good night.
Good night.